Yes, welcome to DC Economics. Today I'm going to take you on how to solve maximization problem by using the Lagrangian formula. For example, imagine that your t function is given by uxy is equal to 5xy squared, and the price of x is 2 and the price of y is equal to 8. You require to set up the Lagrangian to solve the optimal bundle, to calculate the resulting level of utility, and to graph out the relevant curves. So you need to understand that when you apply the Lagrangian formula, the first thing you need to consider our data given. So solution. Now, part A, as I told you, we're required to set up the Lagrangian. So we consider our data given. We are given the utility function xy is equal to 5xy squared, and the price of x is equal to 2, and the price of y is equal to 8, and income is 240. So from the Lagrangian formula, we need to take out L, which is equal to utility plus lambda times budget line. How do we obtain the budget line? Budget line, you consider take out the price of x times quantity of x plus price of y times quantity of y is less than or equal to income. The price of x plus price of y times y is equal to income. So the income, the price of x is 2 and the price of y is 8. So it will be 2x plus 8y, give you 240. Take 2x in the right hand side and minus 240 minus 2x minus 8y. You'll obtain the budget line. Now plug in the budget line, that is 5xy squared plus lambda. Plug in budget line, that is 240 minus 2x minus 8y bracket. Now differentiate. Now before differentiate, take 5xy squared plus times lambda on the budget, on the bracket of the budget line equation to give you 2xy lambda minus 8y. So for that case, now we differentiate dl in respect of dx, and the second time we differentiate dl in respect of dy, and the third time we differentiate dl in respect of d lambda. So we begin now by set up the Lagrangian by differentiate out dl. We consider take out dl. L is equal to 5xy squared plus 240 lambda minus 2x lambda minus 8y lambda. Now when you differentiate dl over dx, this will give out it will give out 5x. It will give 5y squared. Then minus, when you differentiate 2x lambda, it will give you a 2 lambda. This will be the equation 1. Then you consider differentiate dl over dy. That will be equals to 10xy minus, it will be 8 lambda. That is the equation 2. Then we take a dl over d lambda. That will give out 240 minus 2x minus 8y. That will be the third equation. Now after that, now the actual from that point, we could say that we've set up the Lagrangian. Now we consider part B, whereby we solve for optimal bundles for the x, the quantity of x and the quantity of y. Now we take the first equation from the dl over dx, that is 5y squared minus 2 lambda. We take the previous equation, that is dl over dx is equal to 5y squared minus 2 lambda. That is equation 1. We equate out dl over dx is equal to 0. Then we make lambda the subject. It will be 0 is equal to 5y squared minus 2 lambda. So when you make lambda the subject, it will give you now, this is like to say it will be equals to, this will give 0 is equal to 5y squared minus 2 lambda. So when you make lambda the subject, it will be negative lambda. We take 5 in the left hand side, it will be divided by 2. You obtain lambda is equal to 5, negative 5 over negative 2y squared. It will be positive 5 over 2y squared. So lambda is equal to 5 over 2y squared. That is equation 1. Now take the previous equation, the previous second equation, that is dl over d lambda is equal to 10xy minus 8y. The second equation, then equate it dl over dy. Equate dl over dy, that is equal to 0. dl over dy, the dl over dy is equal to 0. Then it will be 0 is equal to 10xy minus 8y lambda. When you equate lambda, it will be negative 8 lambda is equal to 0 minus 10xy. You divide by 8 both sides, negative 8 both sides. You remain with lambda is equal to positive, it will be 5 over 4 xy. So it will be 5 over 4 xy. That is equation 2. Now take the two equations for lambda and equate together. The first equation for lambda and the second equation for lambda. So when you take lambda is equal to the first equation 5 over 2y squared, is that the equation 1, and equation 2 lambda is equal to 5 over 4 xy, that is equation 2. Equate out the two equations. This will give out lambda is equal to lambda. So it will give out lambda, then 5 over 2y squared is equal to 5 over 4xy. Now divide by 5/4 both sides, so as you can make out 5/4y both sides, divide by 4/4 5/4y both sides, so as you can equate out for x. So when you equate out, it will give us x is equal to, there's y square and y will cancel up, 5/4 will cancel in both sides, so it remains with x is equal to 2y. Now take x is equal to 2y, plug into the budget constraint, so as you can obtain the real value of x and y. So we take the budget constraint, that is 2x is equal plus 8y is equal to 240. Plug in x value, it will give you 2 times 2y times 8y is equal to 240. So 4y plus 8y is equal to 12y is equal to 240. Divided by 12 both sides, y is equal to, the y will be equals to 240 divided by 12, it will give you exactly equals to 20. So it will give you exactly y value, that is equal to 20. So take y, that is equal to 20, plug into the x, which is equal to 2y, so as you can obtain the values of x, that is the quantity of x. Or you may plug it to the budget line, or you may plug it to the budget constraint. So y is equal to 20 and x is equal to 2y. Plug in y to the x equations, that will give you x is equal to 2 times 20, which is equal to 40. So for that case, now we can conclude that the quantity of x is equal to 40 and y is equal to 20. These are consumption bundle that maximize the utility. So you may prove your answer by taking these values, this quantity of x and y, and plug in again to the budget constraint. So as you can prove, you could obtain the total income, that is 240. Since a consumer cannot spend more than his income. So 2x, when you plug in the 40, you plug in 20, you'll obtain the answer, that is 240. So it will bring the same answer, the equilibrium, that of income, that is 240. Now after that, let's now look on how we can obtain the level of utility. So actually we may say this is true, since it brings 240. When you plug in 40 and 20 to the budget constraint, it will give you exactly 240. So the consumption for a consumer is actually balanced with our income spending. So let's now find the level of utility. So the resulting level of utility is obtained by taking out the utility function, that is xy is equal to 5xy squared. Now plug in the quantity of x and the quantity of y that we've obtained, that is 40, 20. When you plug in 40, 10 times 20 raised power of 2, it will give you 80,000 as you observe. So we can conclude that and say that the level of utility is equal to 8000. So this is simple, as you observe. So that the resulting level of utility is equal to 8000, as you can observe. So after obtaining the level of utility, now let's look on how we can sketch the relevant curve, the relevant graph, as observed. So we require to sketch out the relevant curve. These are obtained from the previous data that you have made. So this is like to say that it will be, we draw the y-axis and the x-axis. We begin by showing out the level, the quantity of x and y that maximize the utility. That is, in the y-axis 20 and x-axis is 40. So draw the budget line, then construct out a curve, what is known as indifference curve, that cut across the budget line. That gives you the level of utility, that is 800. And here it's the quantity of x that is given by I over px, and the y-axis is given by I is equal to py. Since our income is 240, now divide by the price of y, that is 20. You'll obtain the quantity of y in the upper side. So this will give out 12, as you observe. Then take also income, the total income, that is 240, divided by the price of x, that is 40. You'll exactly obtain 6. So we shade in the upper part of maximization at that level over there, as you observe. So this is the I over px. So we graph out, we shade out that part, as you see. So this is how we sketch the relevant curve. So welcome to DC Economics, and thank you for watching.